Right, hey guys, welcome to my channel. So in this video, I'm going to discuss K-means clustering algorithm, which is an unsupervised classification technique, which means you don't have the advantage of, using your training levels because there aren't any, unfortunately. Having said that, we'll just quickly take a look at how this algorithm works. So let's say you have a dataset D, your dataset of size n, which means you have n points, right? Now you have been asked to classify these points into, let's say, k classes or k clusters. So which means you have to split this dataset into a set of k clusters. So let's define the set of k clusters. This is S1 to Sk, right? Now the next step is, for each cluster you have to initialize a centroid, which means you will have a set of k centroids. For each cluster you will have a unique centroid, which means you will end up with k such centroids, right? Now comes the main part. We have to find the optimal configuration of the clusters by minimizing the following expression. This expression, which is x minus ci summation of all the x's over a single cluster, which is I. So this is nothing but sum of the Euclidean distances between each point. X's are between each point in that cluster and its corresponding centroid, which is ci. This is for a single cluster. So this expression is for a single cluster. Now there are k clusters, hence we have to sum them up. If we consider every cluster, then this is the ultimate expression that we have to minimize in K-means algorithm. Right. Now we can minimize this iteratively by changing Si, that is the clusters, and Ci's, that is the centroids. So first step is we will freeze the centroids first. So first step, let's say step 1 is we'll freeze all the centroids, all the CIs. I will try to form new clusters based on those centroids in the following manner. So we will define new cluster, let's say Si. Si will be set of all those points whose distance to the centroid Ci is less than all the other centroids, right? This basically means we will put all those points inside this cluster which is closer to Ci, the centroid Ci, right? So that is the first step. Now the next step is, after getting this configuration, in the next step we will freeze this new cluster configuration and minimize the expression by updating the value of C, which is the centroid. So the next step is we'll freeze these SIs and we'll update Ci. Now the question is, so what should be the ideal value of Ci for a specific cluster? Well, let's find out. So for a specific cluster, so ideal value of Ci for a specific cluster. Let's find out. So for a specific cluster, we will have this expression, which is sum of all the points. Let's say cluster is S1. This is our expression, right? We have to minimize this. So we'll take the DDC1 and equate them to 0. We have to find the value of C such that this expression is minimized. So this is pretty easy. You will have nothing but minus 2, then sum of, let me keep a bracket here, S1 x minus c1. This is it, equals 0. And this will basically be x1 minus sum of s1 c1 equals to 0, right? This can be written as this. And next is this whole thing can be written as the length or the number of points, right? The sum will be the number of points. And this will be, if we send it into the left side, then this is the ideal value of ci that we will get. And if you look closely, then this is nothing but the mean, right? This is the sum of all the points. This is basically, this represents the, let me use different colors. So this represents the sum of all the points of that cluster, and we divide by the number of points. So this is nothing but the mean of 1. So basically c1 will be the mean of that cluster, right? So that is the minimum, that is the ideal value of c. So the first step is we'll define a new cluster based, new cluster based on the centroids that we have initialized. And the next step is we will change this centroid, we'll update the centroid to the mean of that newly formed cluster. Repeat this process over and over again until convergence. Now we'll take a look at the code. Alright, so I have already implemented the k-means clustering algorithm. So this is the notebook. Let me just walk you through. So we'll first import all the libraries, and this is our dataset which we want to cluster. And we can see that in the dataset, first step is to find the number of clusters we want to form. So we can see from the dataset we can form actually 3 clusters, right? So the value of k will be 3. And here I have used the the animation, fun animation from matplotlib just to demonstrate like easy visualization. So I've created this class here. This is the initialize, like this is the centroid, this is the number of initialize the centroids, random points. Then this is basically what I did is normalize the data, basically scaling the data. And then this is the label, and this is basically print label.shape. We don't need this, never mind. So this is where, this is the implementation of like compute. So basically compute the distance between the sample and all the centroids, and return the index of minimum distance. So this is the implementation. Next is I copied the centroid. So this is my previous centroid, and after updation I have plotted. So basically I have plotted the previous centroid as well as the new centroid. So this is the centroid updations code, where this is basically we're just computing the mean of a single cluster and then updating the centroid. So that is it. Let me just run this cell and it will create a video for us. So if I run this, this is it. If I play this, you can see. So X are the current centroids and plus are the previous centroids. So the cross and the plus sign have overlapped, which means we have reached convergence, and you can see the value of convergence is 0. So this is basically the distance between the previous centroid and the current centroid, right? So this is it. So this is a nice demonstration. Let me just play the video again. It's a nice demonstration of k-means algorithm. So this is how it actually works. All right, adios.